Okay, we're gonna solve exercises that focus a little bit more on common sense, and they all have their own tricks and formulas that you can use, but we're gonna solve them in the simplest way possible without using that many formulas or math topics, rather using a little bit more of simple logic. First one is Synchrony of Events. We're gonna solve 3 exercises of this one. The first one is a typical exercise of admission tests. It's talking about 3 alarms, one that sounds every 10 minutes and the other one every 20 minutes and the third one every 30 minutes. Then it says that if the alarm systems, if the 3 alarms ring together at 9 a.m., at what time will they ring again at the same time? So all we need to do is find a pattern for each one of them. So like the first alarm, I know that the first alarm sounds every 10 minutes. So we'll take 10 minutes, then 20 minutes, 30 minutes, 40 minutes, 50 minutes, 60 minutes, and so on. That will be the pattern of when is the first alarm ringing. Now the second alarm sounds every 20 minutes. So 20 minutes after the first time is going to ring again. Then 40 minutes after the first time is going to ring again. 60 minutes, 80 minutes, and so on. Okay, now the third alarm sounds every 30 minutes. So it's gonna sound for the first time, and then 30 minutes later it's gonna sound again, then 60 minutes later it's gonna sound again, then 90 minutes later it's gonna sound again, and so on. So if I know that the alarms, they sound at the same time at 9 a.m., then I know this 10 represents 9 with 10 minutes. This 20 will be 9 with 20 minutes, 9 with 30 minutes, 40 minutes, 50 minutes, and there is no 9 with 60 minutes. We will have this one as 10 a.m. Okay. So our goal is to find the same time where they all sound again. They all sound again at 60 minutes after they sound for the first time. So it'll be 1 hour later that they are gonna sound together. So the answer wouldn't be 9:30 because the second alarm sounds every 20 minutes. So like it's gonna sound in 9:20, and 9:40 is not gonna sound in 9:30. The answer will be 10 a.m. That's the first time they're gonna ring again. Okay, the first repetition will be 10 a.m. They do sound at 11 a.m., yes, but that wouldn't be the first time that they're gonna sound together. That will be the second time that they're gonna sound together. So it's not 11 a.m. And the other ones are, well, the other ones are p.m., so it will be a lot of time, and they will ring like a lot of times in there. So like it can't be p.m. So the answer will be 10 a.m. 60 minutes after they ring together for the first time. Okay, this other exercise is talking about a train. Okay, train that makes round trips. A round trip is a trip of one way going and then coming back. That's what you call a round trip, a complete trip of leaving and then coming back. The question is how many round trips that this train can do if the train works from 8 a.m. to 4 p.m. and each round trip takes 50 minutes, plus also there's a 50 minutes break between every 2 complete trips. So our goal is to follow the processing here. Okay, so from 8 a.m. to 4 p.m. So let's try to see how many trips can this thing take. So you need to be really good at measuring time, like time in a clock. So I know that 8 a.m. will be the first time that the train is gonna work, okay? Then after 8, the first trip is gonna be 8:50. Then the second trip will be 9 with 40 minutes. If you add 50 minutes, then that will give you like 9 with 40 minutes. And then you have 9:55. Okay, so let's see what's going on in here. Okay, it'll be 50 minutes, yes, for the first 50 minutes for the first trip. For the second one, another 50 minutes. And then remember we have a break of 15 minutes. Yeah. So far we have 2 trips. Okay. 1 and 2. Yes. So we could count them in here. 1 of 50 minutes and 2 of 50 minutes. Yes. So let's keep checking the rest of the trips. Okay, if I add 50 minutes again, then which hour would I have? I would have 10 with 45 minutes. So let's put this thing 10 with 45 minutes. Yes. Then after that, the next trip will be 11 with 35 minutes. Okay, so I will have 2 trips. I'm going to put them here. And then we will have the 15 minutes because we already did, the train already did 2 trips. So 15 minutes more, that will be 11:50. Okay. So 35 plus 15 minutes, that will be 11:50. Then I continue. I will have the next trip will be from 11:50, 50 minutes later, that will be 12:40. Then the next trip will be from 12:40 to 1 p.m. with 30 minutes. Yeah. And then the 15 minutes break, right? So it will be 1:45. So we're getting closer to the end of the day. Then after 1:45 we have the next trip will be from 1:45 to 2:35. If we add the 15 minutes, it will be 2:35. Then we have a second trip from 2:35 to 3:25. Then the 15 minutes of break, okay, that you need to wait for the next trip, pair of trips will be from 3:25 to 3 with 40 minutes. Okay, and then the next trip will be until 4:30, but the train only operates from 8 a.m. to 4 p.m. So those will be all of the trips that you can do. Okay, so let's try to count them. Okay, 1, okay, from 8 to 8:51, 2, this is a break so it doesn't count, 3, 4, another break, it doesn't count, 5, 6, another break, it doesn't count, 7 and 8. So 8 trips. Okay, there's a total of 8 round trips that the train can do. So the answer in here will be 8 trips. That will be the answer. All of the other answers, they wouldn't be correct. The correct answer is 8 complete trips. Let's see another example. Okay, this one is no longer working with time, but like a pattern of distance. Okay, we have a frog, and that frog is at point 0 on the number line, or the origin, point O, or like the origin. Okay, and it plans to jump as follows. So we have a frog that's going to jump in a specific pattern. On its first jump, it's going to jump 1 unit in any direction. It could go forward, okay, or it could go backwards, okay. On its second jump, it wants to jump 2 units in any direction, same way. On its third jump, it wants to jump 3 units. So in every jump, it's gonna jump 1 more unit, and not only that, the pattern is like if it's the first time it jumps, it's gonna jump once. If it's the second time, it's gonna jump 2. If it's the third time, it's gonna jump 3. So basically, like the number of jump is the same thing of like the number of units is gonna move. Question is how many jumps at least, or as minimum, like the minimum amount of jumps that the frog must perform to reach point 11. So what are we gonna do in here? We're gonna have to kind of like make a diagram of how the frog is gonna be jumping. So let's make a diagram of a line, okay? And let's put some numbers in here. We have, let's put from -2. 2 times 1, 0, 1, yeah. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. You don't actually have to do this. Like, I'm just doing it to explain the process. Once you get the idea, the next time you see an exercise like this one, you don't need to make the line because it's a waste of time. And in this type of exercises, losing time is critical. Like, you shouldn't lose any time. You should try to solve things as fast as you can. So you're not gonna be doing this this thing. So I know that the frog at the beginning, the frog is here, okay? This is the first place the frog goes. So I'm only using the diagram so that you understand how the frog is gonna be jumping. If it jumps for the first time, it's gonna move once. If it jumps for the second time, it's gonna move 2 positions. If it jumps for the third time, then it's gonna move 3 positions, okay? Like 1, 2, and 3 positions, yes? Or like 1 after, 2 after, 3 after, yeah? And if it jumps the next time, it's gonna move 4 positions, so 1, 2, 3, 4 positions, yes? And if it jumps the next time, it's gonna move 5 positions, so it's gonna go like way longer than 11, okay? So basically, the frog, you can easily see the pattern, and this is what you're gonna have to do, okay? Like, not using the diagram. What you're gonna have to do is perform some additions and subtractions, okay? Instead of using the diagram, you just need to understand that the frog is always gonna be following that pattern of the next number, and then the next number, and then the next number. So if we understand that idea, I know that the first time is gonna jump 1 position, okay? Then the next time it's gonna jump 2 positions. The next time it's gonna jump 3. Then it's gonna jump 4. Then it's gonna jump 5. Then it's gonna jump 6, and so on. Yeah. So my goal is to try to count all of the jumps until it reaches 11, or the closest number after it passes 11. Okay. So 1 with the first jump is only gonna move to 1. So you can jump like again, okay? So 1 plus 2, that will give you 3. You can still jump, okay, like 1 more time. Plus 3, which is the next jump, it's going to give you 6. Plus 4 is going to give you 10. Yeah. So with 4 jumps, like without going back, because remember that the frog can go in any direction. It could jump forward or it could jump backwards. But why are you going to jump backwards if you're trying to reach 11? Like it's a little bit dumb, right? Like you're not going to jump backwards. You're trying to jump forward. So that's the first thing we're going to try to analyze. Okay, 1 plus 2 plus 3 plus 4. With 4 jumps, the frog can reach 10, but not 11. So it needs 1 more jump. Okay, but the next jump is going to be 5 units. Okay, so the next jump is going to take the frog in position 15, not in position 11. So that thing will give me 15, not 11, which is what I'm looking for. That's where it comes in hand, the idea of jumping backwards. Okay, like for example, what if the first time I don't jump forwards, okay, to the right, but I jump backwards? Because remember that the frog can jump in any direction. So once we get like the minimum to reach like a number a little bit more than 11, okay, if I got 11 at the beginning, like obviously you already have the answer, but in this case I don't, I get 15. If I add like another jump, then I will get like a greater number. So let's keep with this one right now, okay? And let's try to see if we can use only these 5 jumps to get 11. If we don't, then we're gonna need another one. But let's try adding like jumps that go in an opposite direction. So when you're jumping backwards, that jump is a negative jump. So instead of 1, it will be like you jump in a negative direction. So it'll be like you jump to -1, and then you jump 2 positions. Okay. So imagine if you jump to -1, you already moved 1 position, right? Then you move 2 positions, and you're gonna reach number 1. So it kind of like makes sense. -1 plus 2, that will give you 1. Okay. Because the plus and the minus only tell you the direction, if it's going in a negative direction or left, and if it's going on a positive direction or right. Okay, so let's try with the first jump to make it left, and then the rest of the jumps in the same direction. That will change things, right? Like -1 plus 2, that will give me 1, plus 3, 4, plus 4, 8, plus 5, 13. So I'm close, okay? It's not enough with -1, okay? Now what about -2? Okay, so let's see. You might think, oh, if I subtract 2, I'm gonna get 11. No, remember that changing the +2 with -2 is not subtracting 2, because you no longer have a +2. So you're taking first that 2, and then you're adding a negative, so you're basically subtracting 4. Take a look at what I'm trying to say. -1, -2, that will give you -3. Plus 3, 0. Plus 4, 4. Plus 5, 9. So I kind of like lost a lot of distance. So it's not good to subtract that much, to jump a lot in the left direction. Like I said, it would be dumb to jump a lot to the left side. So let's try to make this one positive then. Okay, what would happen then? Okay, let's kind of like recover. The first jump is going to be in the right direction, but the second jump is going to go left, and then you continue jumping to see if we might have an 11 in here. Let's see. 1 minus 2, -1, plus 3, 2, plus 4, 6, plus 5, 11. Oh, okay, I got it. Okay, I got the 11. Okay, so how many times did the frog had to jump? 1, 2, 3, 4, 5 times. One of those jumps was left, the second jump. So the first jump was 1 in this direction. Okay, I'm gonna use like green for positive direction. Okay, so 1 jump in this place. Okay, now the next jump was from here backwards, 2 units. Yes, then the next jump was 3 units. Okay, then the next one was 4 units, and then the next one was 5 units, and I reached the position I was looking for. Okay. So the minimum of steps of jumps basically that the frog needs to do is 5. it cannot be 4 because only jumping with 4, like even only going in this direction, that is only adding, you are not going to get 11, you get 10. It's impossible to do only 4 jumps and reach 11. You need 5 jumps as a minimum. Okay. So the answer will be, the minimum amount of jumps will be 5 jumps. So if you noticed, we're not using any sophisticated formula. We're just trying to analyze the exercise and solve it the way we might think it's suitable for understanding it. Like there's no formula or something that you might need to use in here. It's just trying to understand the pattern and use it to find the answer. Okay. Like if you do have a formula, there are other ways to solve this, but if you have a formula and you know how to solve it faster, then do it. Okay. The goal in this type of exercises, especially in admission exams or stuff like that, or tournaments, is basically to solve it the faster you can. Okay, so you need to solve the exercise quickly and get the answer also. Like, because if you solve it quickly but you get a wrong answer, that's pointless. You need to solve it correctly but fast. That's the idea of these types of exercises.